So again, quadratic modeling, we've got 2 lessons, one today, one tomorrow, 2 different ways of looking at quadratic models. So again, what we did was we started out with, I give you the equation, like I said, with population or the mosquitoes or whatever those things, and you basically have to find the vertex or find a value. And then I gave you data points that you had to plug in the calculator, and you come back with the model. And then right before break, we did the projectile motion, so an object that goes up or an object that goes down. We have 2 applications we're going to do this week, and we're done with this. One is borders. So think of a border like a picture frame, so that's a border that goes around this photo. So we'll talk about how that works in a quadratic model. The other is a fence. So if I build a fence around a house or something like that. So let us talk about this. Being that it is Christmas, we have a Christmas photograph courtesy of, what is that? Awkward Family Photos. I don't know if you've ever been to that website. So anyway, hopefully you don't see anybody you know when you go there. But this is someone, I don't know who these people are. This is their Christmas photo. So we have a 4x6 photo that is in a wooden frame of uniform width. The area of the frame's front face is 39 square inches. How wide is the frame? Okay, so these problems are going to set up pretty similarly. So here's, you want to draw a picture. Okay, so this one's nice and already drawn for you. You've got a picture and you have a frame around the picture. Okay, we want to let X be the width of the frame. So in all of these border problems, X is going to be the width of the border. Okay, so what that means for me, if X is the width of this frame, I already know certain things. What is the dimensions of this photo? Yeah, so this photo is a 4x6 photo. So that means from here to here is what? That's 6, okay. And then from here to here is what? That's 4. So I know that already, okay. Now, what is the width of the frame? What did I say it was going to be? No? What's the width of the frame? Let X equal the width of the frame. So that means that from here to here is X. What's the distance from here to here? X. What's the distance from here to here? X. What's the distance from here to here? X. Okay. So if X is the width of this frame, then I know that this distance, everywhere I see, this is X, this is X, this is X. That width is X all the way around, okay? So the area of the photo, what are the dimensions of this photo? This is a 4x6 photo. So what is the area of this photo? It's 24 square inches, okay? Now, what is the area of the frame? So just the frame, do I know that? What is it? No. So the area of the photo is 24. The area of just the frame, do I know that? Why don't we read the problem again? Why don't we go with 39 inches? Okay, I'm not making that up. Where am I getting that from? Okay. The area of the frame is 39 inches, okay. Now, what I don't know is the area of the frame plus the photo. What would that be? Well, I know it's going to be that, but in terms of trying to figure out what these things are, okay? So I know that what's going to happen here is that I'm going to have the area of the photo, so the area of just the photo plus the area of just the frame has to equal this total area, okay? So how do I find the area of this total thing in blue here? What would it be? What are the dimensions of this side right here? 6 plus what? 6 plus 2x. What are the dimensions of this side? 4 plus 2x. So the dimensions of the frame plus the photo have to be 6 plus 2x times 4 plus 2x. So now this is going to set up into an equation. The area of just the photo plus the frame has to equal this expression right here. Okay, does everyone see how I got that? Okay, so X being the dimensions, the width of that frame, I was able to build something that said, hey, the area of that total frame plus the picture has to be 6 plus 2x, 4 plus 2x. So now this sets up nicely to an equation. I'm going to have 24, that's the area of just the photo, plus 39 is equal to 6 plus 2x times 4 plus 2x. What kind of equation is that? What? Come on, guys. We've only been gone like 10 days. Okay, what kind of equation is that? Yeah, but is it linear, exponential, logarithmic? What is it? No. What are we studying right now? Quadratic. That is a quadratic equation. We used to know how to solve those, okay? So this is what? 63 is equal to 24 plus 8x plus 12x plus 4x squared. How will I solve this? What will I do? Combine terms, move that 63 over. So this is going to give me 0 is equal to what? 4x squared plus 20x, and then 24 minus 63, negative 39. Now, what will I do with that? Well, I would do that if I didn't have what sitting in front of me? If I had a TI Inspire sitting right next to me, I would not be using the quadratic formula, okay? Everything in this unit, you can use your TI. So I can find what are the roots to this polynomial. So menu, algebra, polynomial, complex roots. So it is 4x squared plus, what was it, 20x minus 39 comma x, and I get negative 13 halves and 3 halves. Okay, so negative 13 halves and 3 halves. So x is equal to negative 13 halves and 3 halves. What does x represent in this word problem? The width of the frame. One of those makes sense and one of those does not make sense. Which one does not make sense? Yeah, it doesn't make sense for the width of that frame to be negative 13 halves. So what was the question they asked? How wide is the frame? So that's what I need to answer. So the frame is 3 halves or 1 1/2 inches wide. Okay. So any questions over that? Okay, so we need to wake back up our brain cells that deal with quadratics. What you can do, yes. Yeah. Time you have a border, it's going to set up nicely to be a quadratic equation like this. You go to your calculator to solve it. You're going to probably get 2 answers. One of those might make sense. One of those might not make sense. What if, for example, so I got negative 3 halves, so you knew that that makes sense. What if I got that the width of the border, let's say, for example, if the width of the border turned out to be 50, would that make sense? Pardon me? No, because it's going to violate the total area. It's not going to work. So you may get, the negative numbers are easy. You might get one that doesn't make sense from the number being too large. So take a look when you get 2 answers. One of those will probably work and one of those will not. So let's look at another problem that's similar to this. You are decorating your bedroom and you go find a nice math poster. What does this mean? There we go. So that's tying back to complex numbers. I love algebra. Okay. You decide that you want to frame your favorite math poster. The poster is 11 by 14, and the frame you use has an area of 150 square inches. What is the width of the frame? Okay. So the poster is 11 by 14. Okay. So what's 11 by 14? Which part of this? Yeah, the white part you see there. So it tells me that right here, this side, from here to here, that is 11, and from here to here is what? 14. Okay. So I know that it's 14. Now in all of these, you're going to do the same thing. Let x equal what? Let x equal the width of the frame, and this is measured in what? In inches. Okay. So that means that what is the distance from here to here? Yeah, that's x, and that's x. Okay. So the width of the frame all the way around is x. And so at this point, I know that the area of this white portion plus the area of the black portion equals the total area. Okay. So the area of the white portion is what? How do you find the area of something that's 11 by 14? How do you find the area of a poster that's 11 by 14? It's 11 by 14, right? So 11 by 14 plus, what is the area of just the frame? Yeah, plus 150. Okay, so the area of the photo plus the area of the frame has to equal the total area. So what is the total area going to be? Well, that's the number, but that's not in terms of x. In terms of x, what's the total area going to be? What's the length of this top side, guys? This is 14 plus 2x. These problems are all going to sort of work like this. What's the length of this other side in terms of x? 11 plus 2x. That's the equation that I need to solve now. So what is 11 times 14? So 154 plus 150 equal to, now I'm going to FOIL that right side. So 14 times 11, that's 154 plus 28x plus 22x plus 4x squared. Now to simplify this, I've got this 154 on both sides. So what happens to that? And that cancels out. So I've got 150 is equal to 4x squared plus, what is that, 50x plus 150 plus, that's it. So 4x squared plus 50x is equal to 150. So this is 4x squared plus 50x minus 150 equals 0. And what do I do with that? Yeah, that's where I go to the calculator. So I'll come over here, and so it was 4x squared plus 50x minus 150 comma x negative 15 and 5 halves. Okay, so this represents the what? The width of the frame. Which one of those doesn't make sense? Negative 15. So this frame width is what? Yeah, so the frame width is 5 halves or 2.5 inches. Okay, how about the other homework that you have? This one's a little bit different. What's different about this problem? Okay, well, you're going to power through that because there will be no picture on the task. Okay, so what's different here?
It says the picture frame, not the.
Yeah, what the other started with what? I gave you the area of the picture or the poster. Okay, this one is giving you, instead of that, what is it giving you? So it's telling me that I've got an outer frame that looks like this, and so this is 12 by 20. Okay. Now inside this frame is a what? Yeah, inside this frame is a picture. Okay. Now in all of these, I'm going to let x equal what? Yeah. So let x equal the width, and this happens to be in centimeters. Okay. So that tells me that this distance from here to here, this is x, 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 and x. Okay, that's the width all the way around. Okay. Now, what do I know that I haven't used? The area of the picture is 84 square centimeters, but I don't know the dimensions of the picture. But I can write an expression that tells me. Okay. So if this is 20, so if it's 20 from here to here, okay, what is it from there to there?
No.
20, not 20 minus x, 20 minus 2x. Okay. So the area from the distance from here to here, this has to be 20 minus 2x. Okay. And then if you look at the distance from here to here, that has to be what? 12 minus 2x. Why is it 2x? Okay. If this is 12, the distance from here to here is x. The distance from here to here is x. So this has to be 12 minus 2x. The whole thing is 12. Okay. And to figure out what this piece is, it's 12 minus x minus x. Okay. So what is the equation here? I know that what? 84, that's the area of that picture. What is the algebraic expression? Yeah, so 12 minus 2x times 20 minus 2x. So this gives me 84 is equal to, what is this, 240. That's 20 times 12. And I'm going to have minus 24x minus 40x plus 4x squared. Did I do that right? So 12 times 20, that's 240. Okay. So this gives me 84 equal 240. And it's what? Minus 64x plus 4x squared. I want this to be equal to what? 0. So I'm going to get 4x squared minus 64x plus 240 minus 84 equals 0. And 240 minus 84 is 156. So 4x squared minus 64x plus 156 equals 0. You're welcome to use a quadratic formula, but most of you probably will not at this point, and that's fine. So 4x squared minus 64x plus 156 comma x, 3 and 13. So now we got to think about this. 3 and 13. So I get x equal 3 and 13. What would happen if x is 13? If the width of the frame is 13 inches? Yeah, it's going to look goofy, but it can't happen because this side is 12. How can I have a frame width of 13 if this side is only 12? So it's not going to work, okay? So the only one that's going to work is 3. So this width is 3 centimeters. So make sure that your answer has both words and numbers, and in this case also units, okay? So this was not inches, this was in centimeters, okay? So that's the only difference. So there are two variations of this problem. If I give you the inside dimensions of the photo or the poster, then you're going to have something plus 2x, plus 2x. If I start with the outside dimensions, you're going to have something algebraically that's a minus 2x, minus 2x. But either way, you're going to get a quadratic that needs to be solved. I think that is the end of everything there. Is that right? So that is it. There are other classes that are powering on.